We're starting Unit 3, which is about gathering data. So we're going to be looking at how we can appropriately collect data through surveys and experimentation. But we're going to start with Chapter 11, which is Understanding Randomness. Why be random? What is it about chance outcomes being random that makes random selection seem fair? There are two things. The first is that nobody can guess the outcome before it happens. So you don't know. So that seems to make it fair. The second is that when we want things to be fair, usually some underlying set of outcomes will be equally likely. However, there are many games where the outcomes are more likely than other outcomes, but we can deal with that later. For example, picking heads or tails. If you flip a fair coin, does the outcome match your choice? Did you know before flipping the coin that it would come up heads or that it would come up tails? You didn't. You guessed, and you may have been right or wrong, but either way you had a 50-50 chance of that happening. So randomness. On the next slide, I want you to look at the numbers quickly and pick one at random. Actually do this. Do not just skip this section. It's actually interesting. So, are you ready? On your mark, get set, go. So, what number did you pick? Abby, what was your number? If you picked the number 3, 75% of people would have picked 3. If you picked 2 or 4, 20% of people picked 2 or 4. And if you picked number 1, you are of only 5% of people that would have picked the number 1. We'll talk about this in class tomorrow to see what everybody actually did, but it will break down that the majority of you would have picked 3, followed by 2 or 4, followed by the number 1. When I did it for the very first time, I picked the number 3. That goes to show that it's not actually easy to be random. Random numbers are difficult to get. Our brains do not work randomly, even if you are trying to pick random numbers. You will either start picking numbers in a pattern, or you will end up using your favorite number more often than other numbers. Computers are better than humans, but computers give us pseudo-random numbers. So a pseudo-random number is a number that is generated in a fixed sequence that will eventually repeat itself. So pseudo kind of means fake, so they're fake random numbers. They are almost always going to be good enough. They're virtually indistinguishable from truly random numbers because their pattern is so long. So if you are using your calculator or computer, it will be good enough, but it's still not perfectly random. There are ways to generate random numbers so that they are both equally likely and truly random. The practical randomness is where we imitate a real process so we can manipulate it and control it. In short, we can simulate reality. So a simulation. The sequence of events we want to investigate is called a trial. The basic building block of a simulation is called a component. Trials usually involve several components. After a trial, we record what happened, which is called our response variable. There are 7 steps to a simulation. The first step is to identify the component that is to be repeated. The second step is to explain how you will model the component's outcome. The third step is to explain how you will combine the components to model a trial. The fourth is to clearly state what the response variable is. Then you run several trials. Then you collect and summarize the results of all the trials. And finally, you state your conclusion. When we are doing a simulation, performing the simulation is only part of it. we have to actually explain everything. So you will be required to actually write a few sentences explaining what you're going to do it, then analyze it, and state your conclusion. So, for example, suppose a cereal company is putting pictures of famous athletes on cards in boxes of cereal. 20% of the cereal boxes have a picture of Tiger Woods, 30% have a picture of David Beckham, and 50% have a picture of Serena Williams. We want to know how many boxes of cereal do you need to buy to get all three pictures. Now, in reality, we would go out and buy boxes of cereal until we got all three. However, that would cost a lot of money. So what we would do is a simulation instead, simulating this event. So in order to simulate this, what we're going to do is first identify the component to be repeated. Our component is selecting a box of cereal. So picking out one box, that's a component. Then we have to explain how we're going to model the outcome. Because 10 digits, 0 through 9, are equally likely, we use 0 through 9 because those are 10 digits, including 0. 20% are going to be Tiger Woods, so we're going to use 2 digits to represent Tiger Woods. 30% are Beckham, so we're going to use 3 digits to represent Beckham. And then 50% are Serena Williams, so we're going to use 5 digits to represent Serena Williams. So I would say 0 and 1 is going to be Tiger Woods. 2 through 4 will be David Beckham. And 5 through 9 will be Serena Williams. Then we have to explain how we're going to simulate the trial. Again, a trial is a sequence of events that we pretend to take place. So for this particular situation, we're pretending to open cereal boxes until we have one of each picture. So we will look at each random number and indicate what outcome it represents, and we'll continue until we have all 3 pictures. So our trial will end when we have at least one of Tiger Woods, at least one of David Beckham, and at least one of Serena Williams. So it may end up being that we have a bunch of 2 of them and only one of the third one. And that'll be okay. So for example, our first trial would be 29240. A 2 was David Beckham, the 9 was Serena, 2 was Beckham, 4 was Beckham, 0 was Woods. I would stop here because now I have Beckham, Williams, and Woods. So, again, using the letters, B would be the 2, Serena Williams, B would be Beckham, B would be Beckham, W would be Woods. I'm looking to have one of each. I have one of each. I'm happy with that. The fourth step is to clearly state what the response variable is. The response variable is what we are interested in. In this case, we want to know how many boxes it takes to get all 3. So in that first trial, it took 5 boxes of cereal. Then we run several trials. So the more trials you perform, the better it's going to be, and the more accurate your prediction or your conclusion will be. 20 trials is probably a reasonable minimum if you are doing it by hand. If you have a computer, you would end up running a few hundred. So here I'm showing 5 trials. So these are all random numbers. So in the first trial I had 8, 9, 0, 6, 4. So Serena, Woods, Serena, Beckham. It took 5 boxes. This is my response variable. In the second trial it only took 4. I had Beckham, Williams, Beckham, Tiger. So it took 4. In the third trial, it took us 7. So I had Serena, Beckham, Serena, Woods. Took us 7 boxes of cereal. In the fourth trial, it took us 5. And then in the fifth trial, it took us 18. Sometimes it will take a lot more than others. The sixth step is to analyze the response variable. We want to know how many boxes of cereal we need to buy to get all 3 cards. So in this case, we're going to average the results of each trial. So I would add them all up, divide by how many there are, and I get 7.8, which means that in our conclusion, we would have to buy 7.8 boxes of cereal. Now we can't buy 0.8, so if you round up to a whole number, that would be appropriate. So based off of this, we would need to buy 8 boxes of cereal to ensure that we get all 3 cards. That is it for this lesson. We're actually done with chapter 11. Tomorrow in class, I'm going to go through a few more examples with you guys, showing you how to use a table of random numbers and how to use your calculator. And then we'll spend the next couple of days just working on homework. I'll see you guys tomorrow. Have a great night.